Okay, we're up to video 6 in the series. Again, this is, I have to show you all the steps, but at the end it comes out to be some nice, neat formulas that we're going to use. So, start off with just some what we're calling about resolution of vectors. So we're going to break up a vector into components, into parts, and this is called resolving a vector. So resolution of a vector is breaking up into parts. It's also called resolving. So copy that and come across when you're ready. Okay, so just some basic things. So if I've got a vector r equals some number I plus bj, if I multiply r by a unit vector I, okay, so I is just a unit vector in the direction of I end up with ai plus bj times I, and then I'm going to just expand it out. So I've got a times I plus b times ij, and again ij equals 0, I equals 1, so we just end up with a. And similarly we've got a times ij, which is going to go away, plus b times j, which is 1, which is b. And so what does this mean? Okay, come across. So if I take a vector and I multiply it by a unit vector in the I direction, I get the scalar component of r in that direction. Okay, so just remember that r equals ai plus bj. If I multiply r by I just get the scalar component in the x direction, and if I multiply it by j, I just get the scalar components in the y direction. Okay, so how is that useful? Okay, come across and we'll have a look. Okay, so I've got this force vector again, maybe force vector, which is acting on a particle to move it in this direction. Okay, so I'm trying to get the projection, the resolute of A in this direction. Okay, so we've got a right angle triangle, and again, just use some basic trig. So I've got cos theta equals OM on OB, and so that OM will be OB times cos theta. Now OB is the magnitude of B, okay, times cos theta. Now this is where I just do a little bit of a trick. Okay, so far it's all okay. Now I'm going to put B, I'm going to put the number 1 because that doesn't change the sum, but this is where again is the trick. If I've got 1 as my answer, then that would be the same as the magnitude of a unit vector in the direction of A. Okay? So if the answer is 1, it's a unit vector. Okay, like this is the magnitude of a unit vector. So now I've got b times a hat times cos theta, and from the definition of dot products, that means I've got b dot a hat. Okay, so this is the definition, falls into the definition of a dot product, where you've got two magnitudes times the angle in between them. Okay, so what this means is the scalar resolute of B onto A is equal to B dot A hat. Okay, now this thing called the scalar resolute is also called the projection. We talked about that in an earlier one. So it's projection of B onto A. Now, this is a scalar. If I want to make it a vector, okay, so a scalar resolute is a dot product. If I want to make it a vector resolute, so it has magnitude and direction, I've just got to multiply B dot A hat. Okay, so that is the scalar resolute. It has to be in the direction of A, so I just multiply it by the unit vector A. So this is how long the vector is in this direction. Okay? So the vector resolute is found by coming from the scalar resolute. So copy that down and we'll have a look at an example, I think, on the next slide. Okay, so hang on. No, so I've just repeated that again. So the scalar resolute is also referred to as the projection. Okay, the scalar resolute of B onto A is the projection of B onto A. So I mentioned that in the previous slide. Hope the next one's an example. Nope, next one is, we're not going to an example yet. We're looking at, so here's B. This is the direction of B parallel to the particle moving, and this is B perpendicular to the particle. Now, if I'm just going to use some, if I want to get this vector in this direction, I've got to go backwards along the parallel, and then I can go forwards along B. So B perpendicular is minus B parallel, then add the vector, and I just change the order to put the plus in the front. So I've got B minus B times A hat times A hat. Okay, so this will be on the next one with an example. So I'll have breaking it up into components parallel, breaking it up into vectors perpendicular. Okay, so come across. I think next one must be the example. Okay, so I've got two vectors, u and v. I'm going to find the unit vector parallel to u, then I'm going to do scalar resolutes of v onto u, a vector resolute of v parallel to u, and a vector resolute of v perpendicular to u. So even if this is the question that you actually asked in the test, you've got to go through all of these steps to get to that final answer. Okay, so we'll start off with unit vector u. Okay, so it's going to be 1 over the square root of 1 squared plus 3 squared, okay, which is 1 over root 10. Sorry, 1 over, yeah, I think that's right. Oh, so in my example, can I just change that to a 2? In my notes I've got so 1 plus 2 squared equals 1 over root 5. Okay, so that's part A. Part B, okay. I've got to find it. So that's the magnitude, the unit vector. I'm still on the same question. So u hat equals 1 over root 5 times the vector I plus 2j. So that's part A. Because it's got a unit vector, I had to find the unit magnitude, I have to find the size of it, and then I'll go 1 over it. So that's, can I just, this answer here, the size of it, the size of u is 1 squared plus 2 squared, which is root 5, and then the unit vector is 1 over root 5. So sorry about that. I'll try to remind you that I've made a mistake there. Okay, part B. Okay, so the scalar resolute will be v times u hat. Okay, so it's going to be 3i plus j multiplied by 1 over root 5 of I plus 2j. Okay, so then just do your expanding brackets. So take that number out the front, and then all the, because we're going to have those ij's and things like that, ends up just being 3 times 1 plus 1 times 2. So it's going to be 5 over root 5, and that actually equals just root 5. Okay, so how long parallel is going to be root 5. We wanted to do the vector resolute parallel, so the vector, so that's parallel, this is parallel, will be root 5 multiplied by, so go back to the formula, sorry. So I'm going to have v dot u hat hat. So it's going to be root 5 times 1 over root 5 I plus 2j, and then the root 5's cancel out. So this is going to be I plus 2j, and the last part, the vector resolute perpendicular. So the formula is going to be V minus V parallel. So it's going to be 3I plus j minus I plus 2j equals 2I minus j. Okay, so I'll find an exercise for that and stick it up on Moodle for you to do. And that's it. Bye.